All right, this week's going to be about flow control. So if you got a chance to look ahead as to what flow control is all about, this is where we start to take our program and use a little bit of control statements in order to dictate what we're going to do. So for example, in this flow chart, we can see that we start, we find out whether or not it's raining. If it's yes, then we ask a question whether or not they have an umbrella. If it's no, then we go ahead and ask for wait a while, then go back and ask them if it's raining, then send them back through other loops all the way out. So this gets into your control statements, which in our case is going to look a little something like Boolean. And in this case, we're going to deal with if and elif and else statements and whiles, loops, and all sorts of other flow control. So the first thing that we're going to talk about is if we review the data types that we've covered so far, we've talked about integers, floating point, and string data types. We also have one called Boolean, and Boolean only has two values. It's either true or it's false. Note that those are capitalized, so capitalized true and capitalized false is important because if it's lowercase, then it means something entirely different. All right. So when we look at, say, we set spam equal to true, and then if we ever check spam, it's going to be true. If we just type in true as lowercase, we're going to get an error back because true would then be a variable that we have not defined. And if we say true with a capital T is equal to 2 plus 2, that's not going to give us anything, right? Whatever it equates down to would have to be true, or whatever expression we use would have to be equal to true. And so to check those, we use comparison operators. They're also known as relational operators. And we're trying to compare two different values that'll evaluate down to a single Boolean value. So if we have a double equal sign, this means equal to. If we have an exclamation point, equals is not equal to, less than, greater than, less than or equal to, greater than or equal to. And we can use these numbers to define as to what's going on. So if we type these in on our idle, we can test those different ones out. Now, the one that usually messes people up is going to be the equal to and the equal sign. So there's a difference between a double equals and a single equal sign. Remember that a double equals is the equivalent of saying equal to, making sure that two values are the same as one another, where the equal sign is an operator, and it puts the value right into that variable that's assigned. So a lot of times when people do if checks, they tend to put a single equal sign. That's not what you're looking for if you're looking for equal to. All right. We also have things called Boolean operators. Again, Boolean values are different than Boolean operators. Boolean values are just true and false. Boolean operators are things like and, or not. When we deal with those, they're all binary, meaning that true and true is equal to true, and true and false is going to be equal to false. And these are known as truth tables. And you'll see these truth tables down below here. So if we use the word and, or the Boolean of and, then if it's true and true, then it's true. If it's true and false, it's false. False and true, it's false. False and false is false. Okay. Or tables are going to look like this. If it's true or true, it's true. It's true or false, it's false or true. False or true, it's true. And false or false, it's false. Okay. Does everybody see where those truth tables come from? Should be some general logic that you guys have done throughout high school. Then all you have is the not operator. The not just makes it the opposite, right? So if it's not true, it's false. And if it's not true, it is false. If it's not true, then it's false or true, depending on how many nots you put in front of it. Okay. Anybody have any questions over truth tables? All right, so to mix things like Boolean and comparison operators, we can look at these type of evaluations. So remember that parentheses comes first. So if 4 is less than 5, what are we going to get inside of this parenthesis? True, right? So then we have true, we have and if 5 is less than 6, and therefore we have true and true, which is going to evaluate down to true. If we have 4 less than 5 is true, but 9 less than 6 is false, true and false is going to give us false. All right. And you can mix this up and do massive strings if you wanted to out. You're still going to come down and you get evaluated just like any other expression. All right, now we're going to get into elements of a flow control. We have a part that's called a condition, and those are always followed by a block of code that is called a clause. All right, so conditions are like Boolean expressions that we've seen so far, where it's just a more specific name in the context of flow control statements. Those conditions are always going to evaluate down to a Boolean value of true or false, and those flow control statements are going to decide what to do based on the condition of whether it's true or false. So blocks of code, we're going to talk about different blocks of code. So far, we haven't really done things in blocks. Blocks themselves always begin with an indentation and end with that same indentation. So in Python, indentation matters, an indentation being the tab key. Okay. Blocks that begin with the indentation increases, blocks can contain other blocks from within it, and blocks in when the indentation decreases all the way to 0 or the containing block's indentation. So for example, if we look at this here, we have name equals Mary, password equals swordfish. If name equals Mary, remember that double equals Mary. These are assignment operators. Notice how print is indented, and that's because we're using an if clause, and we're going to talk about ifs here in just a little bit. So we are going to have some condition, and in this case, we're checking to see if the name is equal to Mary. Well, we happen to have set that. Therefore, it's going to call the code that is inside this block. So the next thing we'll do is say print hello Mary. If password equals swordfish, which it is, then we're going to say print access granted. If password was anything other than swordfish, we would run this else clause and print wrong password. If the name was not Mary, in other words, this did not evaluate to true, then nothing would happen because we don't have an else statement over here. So this explains where blocks are. This is your first block. This is another if statement. So this is an inner block. Okay. Anybody have any questions? All right. When we deal with Python and program execution, we have a py file. And if you print all that source and put your finger on each line, it's going to print it all the way out. Not all programs execute by simply going straight down. For example, what we've been doing so far. But you can likely use your finger to trace and see what's going around. So far what we're writing, in other words, is top-down approach. When we get into functions later on, then the program can jump around quite a bit. For now, the first flow control that we're going to work with is if statements. And this is pretty simple with the flow chart that we talked about before. So an if statement is always going to have the if keyword. It's going to have some condition after it that is either going to evaluate to true or false. It's going to have a colon after that condition. And then starting on the next line is going to be an indented block of code. So in its most basic form, if name equals Alice, notice the colon, then we indent one line and we say print hi Alice. If name is not equal to Alice, this does not get executed. It just ignores it and keeps moving on. Does everybody understand how ifs work? Okay. If we look at it in a visual perspective of a flow chart, we start, we check to see if that name is equal to Alice. If it's true, then print this. Then in the program, if name is not equal to Alice, then we say false and in the program. It's very helpful when you guys are first getting started to build flow charts like this. And if you go out here in our weekly assignment, you can go out to diagrams.net. These help you build flow charts. And I encourage you guys to kind of flow chart out some of your programs. I wouldn't say do everything, but it's nice in the beginning, especially when you start working on your midterm project. You may want to build some kind of overall flow chart to understand where your program is jumping all over the place. Okay. Along with ifs, we have the option of doing else statements. They're not required. We just have the option of specifying those, which means right now, if that if statement is not true, in other words, the name is not equal to Alice, the program just ends, nothing happens. But say we want to print something such as that name is not Alice, or something to let the user know that that condition did not get met, then we can use the else statement. In an else, it's just the else keyword with the colon, and then we indent the line. So for example, if name is equal to Alice, print hi Alice, else print hello stranger. Note that there is no condition after else. A lot of times students try to stick something in there, it'll break the code. All right, so it looks something like this versus this one up here. In this one, when it was false, we just ended the program. Now, if it's false, we're going to print hello stranger, then end the program. But an else is not required. Okay. Seems fairly quiet. Evidently, everybody's following along. We also have elif statements. So if we want to do more than one check in a sequence, we can use elif statements. Again, it's not required, but we can use as many of these as possible if we want to check in a big block. So we could have if name equals Alice, print hi Alice. If the age is less than 12, then say you are not Alice kiddo. All right, looks a little something like this. We start, we check to see if the name is equal to Alice. If it's true, print hi Alice in the program. If it's not true, then we check to see their age, right? And if their age is less than 12, it's false end. If it's true, then we say you are not Alice kiddo, and then end the program. Does anybody know the advantage of doing an elif here versus another if? What's that?
If it's another, sorry.
Good.
If it's another if, then
the code's going to get executed in this sequence. So if we do if name equals Alice, print hi Alice, then we do if age is less than 12, print Alice, you're not a kiddo. We may end up in such a case that we don't get either this statement or this statement. That's the reason we do an elif. You're either going to get this one or you're going to get this one. But if the name is equal to Alice, but their age is greater than 12, then there's no chance of this part ever getting executed. Does that make sense? Up here, the first check is finding out whether or not their name's Alice. If it's Alice, this thing never gets checked. It does it in order. The moment this hits true, then this is going to print, the program goes on. It does not check age at that point. So the reason we would do elifs in here is to do other circumstances based on this initial check. If we do an if down here, it doesn't matter what the name was up above. Here, the name has to not equal Alice for us in order to execute this code. Does everybody kind of understand why you would use elifs? All right, you can chain as many of those together as you want. So for example, if the name is equal to Carol and the age is 3000, if the name is equal to Carol, now we're doing a check, then go ahead and print, or in this case, Alice, sorry, print hi Alice. Then the program just ends. Otherwise, we're going to check to see if it's not Alice. Then we're going to see if the age is less than 12. If it is less than 12, then we're going to go ahead and print this statement. The program ends. If we're greater than 12, then we're going to check to see if the age is greater than 2000. And we're going to say, unlike you, Alice is not undead, immortal vampire. If that is not true, then we're going to check to see if the age is over 100 and print, you are not Alice Granny. Does everybody get the idea of what these elifs are doing? We're checking in this order. So we're first going to check if the name is Alice. Then we're going to check to see if they're less than 12. Then find out whether or not they typed in an age that was over 2000. If it's under 2000, then we're going to go ahead and check to see if it's over 100. and tell them that that's probably not a valid age. So we can do a series check on everything that they typed in. And you can see from this visual what a flow chart looks like on that. The idea being that the order of this elifs really matter. So we may want to move something like this check in front of the check to find out whether it's greater than 100, right? If we do that and we move this one up here, then what happens if they say their age is 3,000? Nope. The first time that this thing evaluates to true, that's what gets printed. So it's a good point. That's the whole point of that. If age is going to be greater than 100, that's going to say true. Therefore, we print Alice, you're not a granny. This will never happen, right? The only time this would not happen is if we say the age is less than 100. You know, say we typed in 33. Then this would get skipped, but this would also get skipped. So you have to be careful on your order of when you're doing your elif checks to make sure that this would ever be called. So you may want to put this ahead of the 200 check. Does everybody see what I'm talking about there? The order of your elifs matter. All right. You can also chain an else at the end. So for example, if we have if name equals Alice, print hi Alice. Elif the age is less than 12, you are not Alice. Then we can hit the else statement. Think of an else as a catch-all. If it doesn't match anything up above, this is what's going to happen. And in this case, we're going to print you're neither Alice nor a little kid. Anybody have any questions on if statements? In the beginning, your programs are going to mostly be comprised of the if statements. So understanding if, elifs, and else. If I have an if statement, do I have to have an elif? Do I have to have an else? How many elifs can I have? How many else's can I have? All right. While loops. So while loops are going to keep you in an indefinite loop until that condition matches true. Or I'm sorry, till it meets false. So a while loop is going to look something like this. We could have this statement that says spam equals 0. If spam is less than 5, print hello world. Then we're going to add 1 to spam. So spam now equals spam plus 1. So when this code goes on, what happens? What's the next line that gets executed in this piece of code after spam equals spam plus 1? It just ends, right? There's nothing to keep this looping back over. So that's why we would use a while statement, and we can say while spam is less than 5, print hello world, and spam equals spam plus 1. Once this happens, spam up here is now equal to 1, and therefore we'll go back into this while loop because 1 is less than 5. Then it will print hello world again and keep this loop going until spam equals 5, at which case this would become false and we end the program in this case. And you can see this loop as it goes through versus this while loop that actually keeps it going continuously until this evaluates to false. You can also do something like this one. They always have you do the annoying while loop. So you say name equals blank, while name does not equal, right? Exclamation point equal means does not equal your name. Please type your name. We give name equals input and then print thank you once they actually type it in. So why is this an annoying while loop? All right, says type my name. I type my name, it just keeps going, right? Doesn't matter how many times I type your name. It's not going to work until I type your name specifically. Seems minor, seems catchy, but the idea is that you have to match this specifically. So if you want to have somebody match something specifically, in other words, you're getting input from a user, right? We may want to check to make sure that that input is valid before we continue on. If you remember last week's homework assignment, when you asked for their age, you could have put in Jason and it would have broke your program, right? Because you were trying to convert it to an integer. So you would want to do a check potentially to make sure that they typed in some kind of number. And if it's not a number, prompt them to type it in again. And we're not quite there yet for converting integers and things like that, but we're getting to that point where we can start doing checks. One of your favorite loops in this whole class is going to be while true, which means that program is going to go on forever until you end it. Or that piece of code is going to go on forever till you end it. Which means if I want to sanitize your input, in other words, I want to make sure that you typed in something valid, I will keep you in a while true loop until you give me what I want. So if I ask for an age, then you better give me a number. And you better give me a number that's realistic, not 2,000 years old. That's what while trues are going to be useful for. So that means while we're in a while loop, we need a way to break out of it. So we use a break statement. Right? So we can check our little program that we had. We can say print your name. If name equals input, and we say if your name, after they typed it in, is your name, type break and break them out of this while true loop. That puts it as while true at the top instead of saying while name does not equal your name. This is a better way of doing it because now we can keep them indefinitely in this while loop until they type it specifically. And we can actually do something when they do type it the correct way. We could have some kind of print here, which is what we have after the fact, or we could do some other calculation or ask them another name. So while trues, again, are going to be your friend while you're working through your code. We have break statements to keep us out of the loop. If something matches something else, but it isn't quite right, say they type in Jason instead of your name, and we want to do a check to see if they typed in Jason, then we can say, okay, thanks, Jason, but I'm really looking for your name. Then we would have to use a continue statement to continue that loop back over again. The first thing people will do when they start working with while loops is set up something like while true, and then we type something like print hello world. What happens if I don't put a break statement there? I'm inside of a while true, right? That means when I get in here, this program's just going to run forever. So if you ever catch yourself in this situation, you hit Control C on your keyboard, and that will break you out of that while loop. Otherwise, that while loop is just going to print forever. All right. So if we look at this little piece of code here, we say while true, which means we're going to be stuck in an infinite loop until we break. We're going to print who are you? We're going to get the name from an input. And if the name does not equal Joe, then we're going to continue on to the next check, which would be this password input. Actually, it'll be print here, right? Their indent's a little bit off, but that's the intention. Then it'll say, hello, Joe, what is the password? Is a fish. And then you're going to print down here and get these access. So if we look at this flow chart, we get into a true loop, and we're going to say, who are you? We gather the name. If that name does not equal Joe, then we hit continue and loop them around until that's false. We say, hello, Joe, what is your password? And loop them back down. Anybody have any questions there? So we have if statements, elif, and else. Those are all blocked together. We have while statements. What are the two keywords, or what's the keyword to get me out of a while loop? Break, right? What does continue do? Keeps the loop going. Goes on to the next line of code in there and keeps executing that same loop over and over until you break out of it. Note that you don't necessarily have to have a continue statement, right? If you want it to just automatically continue, it will automatically continue. The difference between using a continue and not using a continue is a continue will continue with the rest of the code. Where if you don't put that in there, it's going to go down to the next line immediately. So it may continue executing code in a path where you want it to start the loop back over, depending on how you have your code organized. While loops are going to go until the condition equals true, for loops are going to be more precise. So in a for loop, we have for the keyword, we have some variable name, we have a keyword of in, and then we're going to have a call to the range method for up to 3 integers we'll pass, and we'll talk about the range method. We have a colon, and then we're going to start on the next line. So what does that look like? We have print my name is for I in range of 5, the number 5 in here. Print Jimmy 5 times. We're going to string in I, which is a number, and go through. So what actually happens here? This range command is going to start at 0, right? Let's just copy this in and see what happens. Notice that we have my name is, which is this print statement here. Then we're going to start a loop. The first time we go in this loop, this range command is giving us a 0, right? Then we actually print the 0 inside the parentheses here. And then we start this loop back over. The second time I is now 1, then 2, then 3, then 4, then 5. Once it's 5, it no longer matters. Now in this case of range, it's actually 0 to 4. And we'll explain range here in a little bit. All right. So when you're working with the range command, there's 3 different spots that you have in there. You have a starting, which is the first number that you're going to start at. In this case, range is going to start at 12. You have the second number, which is where we're going to stop. It goes up to this number, but does not include it. So if we go back and look at our range 5, notice that we only got 4. Range with 5 in there means we're going to get 0, 1, 2, 3, 4. But we do not get 5. It does start at 0. If we wanted to start at 1, what would our range command look like? So instead of this starting at 0, how could we get this to start at 1? What's that? Yep. 1, 5. That will start us at 1, go up to 5, but not include 5. So if we look at this one, notice how we started at 1, went up to 5, but did not include 5. You also have the third option, which is called stepping. This allows you to step in certain increments. So say I wanted to go by 2s, I could do a 2 back here. And if I run this, I'm going to get 1, 3. Note that I don't get 5 because that would be the next number, but we're only going up to 5. If I want to go in 3s, I can do 3s, and I would get 1, 4. If I go by 4s, what should I get? Just 1, right? There we go. So range command, if you just give it 1 number, that's going to be what it goes up to. If you give it 2 numbers, then the first number is going to be where it starts. The second number is where it stops. If you give it 3 numbers, the first one's where it starts, second one's where it stops, goes up to, but does not include. And the third one is what increment we're going to go up by. If you look at while loops, you have something like this. While I is less than 5, we can print this out. In other words, this is the equivalent of a for loop, right? If we look at the for loop of saying for I in range of 0 to 5, we can do an equivalent with a while loop. For loops are just more precise. We know specifically what we're going to do in those. While loops are a little bit varied. All right. Anybody have any questions on for loops, while loops? If statements? Okay. The next part that we're going to talk about, so far you guys have been using what's called built-in functions. So you've used a print statement, you've had a input, and you've used len. Does anybody remember what len does? Yep, calculates the length of whatever you pass it. Those are all part of Python's standard library, which means they're all built in. You guys didn't have to do anything to get those. There's a whole lot of other modules that are available to you guys that we'll learn throughout this course. One of those is part of the math module called random, and that allows us to get a random number. Anytime we want to import another module, we use the import keyword, the name of the module that we want to use. Sometimes you can use more than one module separated by a list of commas. This is no longer recommended. Python allows you to do it, but it's not best practice to do that. You want to do an import on every single line. So if we look at this line here, we start off with our program like this. We say import our random module. And then we say for I in range of 5, we print random.random int 1, 5, which means we use this random module and we're going to use the randint method, which we give two numbers. We give the number that we want to start at and the number we want to end at, including that number. In other words, give us a random integer between 1 and 10, including 1 and including 10. Then we're going to print that on the screen how many times? What's that? 5 times, right? Notice how he gave us a different number every single time. If I run it again, I should get different numbers. And every time I run it, I'm going to get a different number. Anybody have any questions there? All right, you can import a bunch of different modules all at once, like what you see here, import random, sys, os, math. It is better that you use a different import line for every single one of these. And I'll explain that as we get further in the semester. But instead of doing this, it's better that you do import sys, import os, import math, and do not do it like this. Yes, it saves you lines of code doing it the other way, but it's not best practice overall. Specifically, if we want to check to make sure one of those modules is available, we can't do it if they're all in one line. All right. Instead of doing import random, we have the option of doing from import statements. If you'll notice, when we wanted to use random int, we had to say random dot randint, then give it the number. Notice if you start to type these things inside idle, if I pause here and don't type the 10, it's going to tell me what I can use inside that parenthesis. So it says return a random integer in range of A to B, including both endpoints. So I could say 1 to 20, and it's going to return me a random number between 1 and 20. In order to call this particular method, or function, I actually have to type in random dot first because I imported random up here. Another option I could do is use what's called a from statement. And I could say from random, import randint like this. Now I can just use randint wherever I want, 1, 10. And it would go ahead and create a random number at that point. I don't have to put random dot in front of it. Okay. There again, this isn't always recommended that you do it this way. It's better that you import it so you know what module it came from. If we do this, we have no idea that this came from the random module. We just have this function available in our code. However, if we're building really lightweight code and we want to keep it as small as possible, this will technically make your program smaller because we're just importing the one function that we want to use versus importing everything out of random. And if we were to actually go look at random as a file, you're going to see it's a really long Python script with a bunch of different functions in it. Another place this is useful is later in your code, later in the class, when we start using more than one file, you can use from random import star, which imports everything out of random locally to your file. So I can just call random it directly. I could also call random choice. I could call anything else that would be available there. There's a bunch of other functions. All right. If you want to end your program early, say you get to a specific point, you want them to type exit in your program. If I just type exit, let me get back to where we got some code on the screen here. Okay, we print this. If I just type exit here, this will end the program and it prompts you with this little screen here. Do you want to kill it? I hit OK and it ends. Another way of doing this is import sys. Then instead of exit, I use sys.exit. Run this. The program will run and then it just stops. It doesn't prompt me to end the program. So it's preferred that you use sysexit versus just typing exit where they have to click the OK button to confirm they're ending the program. You can technically put in text here. And if I run this, notice how this sysexit is in red. You have the ability of doing this. I would prefer that instead of you putting this inside the sysexit, that you just do another print statement to say the exact same thing. That way it's actually clean when it prints out to the user. Anybody have any questions on the sys function, sys module? Remember, to do that, you have to import sys up at the top, and imports always go at the top of your script. So when you guys have homework assignments, you should have your 3 initial comments. You should have an explanation of whatever this project is, which is usually this last one, say assignment 1. If this is a longer assignment, like a midterm project, you may have a longer one here telling me what the program actually is. And then immediately I should see all of your imports right after that. Doesn't matter if I don't use it till clear down at the end of the program. I need to see your import sys at the top, your import random at the top. Any other packages you import should always be at the top of your program. And the reason for that is later on when we start using potentially third-party packages, you guys may use that for your final projects to get your OOP requirement. It's easier to know whether or not I've got those packages installed at the top versus trying to dig through it in your code. Because otherwise I can test right away to make sure I have all the modules needed for your script. If not, the program's going to crash at some point inside of there, and then you lose points. All right. You're going to go through a little program here that's called guess the number. And if you actually look at this code, it's going to take you through importing a random number. Then we're going to generate a random number. We're going to print, I'm thinking of a number between 1 and 20. And then for guesses taken in range of 1 to 7, this means that we're going to ask the player 6 times, take a guess. We're going to take their input, convert it to an integer, assign that to our variable of guess. We're going to immediately check that with an if statement. If guess is less than the secret number, say your guess is too low. If guess is higher than your secret number, say your guess is too high. If it hits else, which means what? We checked for too low, we checked for too high. What's the other condition?
Yeah.
You got it, right? If they got it correct, we're going to go ahead and break out of this for loop. And then we're going to say if guess is equal to a secret number, which it should at this point. Say, good job, you guessed your number in this. Else, nope, the number I was thinking of was this. And the reason for this check down here is we can break you out of this, but if they get to their 7th guess and their guess does not equal the secret number, then we would tell them, nope, I was thinking of a different number. So if we play this short little game, didn't copy and paste it correctly. Okay, so we take a guess. If I type in anything other than a number, the program's going to crash, right? Because we immediately try to convert it to an integer. Again, for now, assume that they're going to type in the right answer. So we take a number between 1 and 20, and if we say 44, the guess is too high. At this point, we're not even checking to see whether or not it's a valid number. Okay, we have 20, we have 10, it's too low, 15, too low, 17, 18. The number they were thinking of was 19. So we have 6 guesses, and we run through that. Does anybody know the problem with 6 guesses? What's that? Not enough? Or is it too many? How do you play the guessing game? It's between 1 and 20. What's a good way to start? Middle, right? At least a good programmer or good troubleshooter always starts in the middle and cuts it in half. So we got 10. Well, okay. Obviously, that's too many guesses. Go 10. It's too low, which means we go to what? 15. That's too low. Then what? 18, right? Because I still had 3 more guesses, I could have guessed every single number in between there just by cutting it in half. In other words, you can't really fail unless you type in the wrong number. Why is that important? If you're going to build games like that, you kind of want to make sure you don't give them too many guesses. Everybody kind of see what I'm talking about? If we go back and look at this code, how could we improve this code here? Well, we could always change the number of guesses. But what was the issue when I went over here and first started this, right? No option to play again. We could come back to that. What happens if I type 50? It's supposed to be between 1 and 20, right? So there's nothing to limit them to make sure that they only type in a number between 1 and 20. So where and what could we do to this code to try to get us in that realm? While statement sounds good. I like that. Let's do a while true. We're going to get their guess, right? Convert it to a number. And then the first thing that we're going to do is make sure that that number is between the range that we think it is. So if guess in range of what? 1, 20. Does anybody think it should be different? No, well, it's close. Give us the numbers between 1 and 19, right? But not including 20. So we have to go to 21. Remember that on randint, it includes both sides. In range, it only goes up to that last number, but does not include. So if our guess is in this range, print, well, we don't really need to print. So we can come up here and only print If it's not in that range, print that number is not valid. Please try again. Then we can say what? Continue. That will start that loop back over. Else break. That will break us out of that while loop and continue on with this guess that we started down below here. So now if we run this, we take a guess. If we type in 77, it one, doesn't go against our number of guesses, and two, it tells us it's not valid input. So if we do 10, of course I got it right away. What's another thing we should do here? We should put a space here, right? Because we're mixing our number in with our guesses. We should have a space there so it prints cleanly. All right. The reason I took that little bit of extra time to take you through there, I encourage you to go through and build little programs like this, rock, paper, scissors. People will do rock, paper, scissors, Spock. There's all sorts of ones you can do in there. But the idea is that you should do some of those exercises because you'll really start to understand the Elifs in here. And there's some practice questions here too. When you get into this week's homework assignment, which we'll cover a little bit on Wednesday and kind of get you some more practice in there, review these so that you're familiar with what's going to be required on Wednesday. Remember, no classes on Friday in here. Okay? Unless otherwise stated, but that would have to be some reason that we got class canceled in the middle of the week or something like that. We'll see you Wednesday.